All right, let's get into it. Today, we're going to talk about something in Java that I promise will change how you think. It's the moment you stop just writing code and start designing it. We're talking about abstract classes. And we're going to kick things off with a classic problem, one that every single programmer runs into, to see how this one feature gives us a super elegant way to solve it.
Okay, so let's set the scene. Picture this, you're building a graphics program. You've got rectangles, you've got triangles, maybe some circles, a whole bunch of different shapes. Now, one thing's for sure, every single one of those shapes has an area, right? But here's the puzzle. What about a generic figure class? The parent class for all of them. How could it possibly have an area method that works for everything? I mean, the formula for a rectangle's area is completely different from a triangle, so what do? How do you handle that?
And this visual, it pretty much sums up the whole issue perfectly. See, our figure class, it knows that the idea of an area has to exist. It's like, hey, any class that's a child of mine must have a way to calculate its area. It can lay down the law, create the contract, but there's no way it can provide a one-size-fits-all bit of code to actually do it. That question mark you see, that's the whole problem right there. Figure can't do the calculation, but it absolutely has to guarantee that its kids, rectangle and triangle, get it done.
So, what's the solution? Well, we make that contract official. And that's where the abstract keyword comes into play. And let me be clear, this isn't some hack or a workaround. No, this is a seriously powerful design tool. It lets us set up a blueprint and then say, okay, I've defined the rules. Now you, the specialized classes, you go figure out the details. Okay, so what is an abstract class, really? Well, here's the absolute most important thing to remember. You can't create an object from it. You can't just go new figure MP. The compiler will just say, nope. Think of it like an incomplete blueprint for a house. It might have the walls drawn in, maybe even some windows placed. Those are like its regular working methods. But it also has these big blank sections, these empty spots that are left for someone else to fill in. And that someone else is its children. And those blank spots we were just talking about? Yep, those are the abstract methods. An abstract method is basically a promise. It's a rule. It's like a mandatory item on a to-do list that gets handed down to any class that inherits from it. You'll notice it's just the method name and parameters. There's no body, no curly braces with code inside, just a semicolon at the end. It's a contract, and it's basically shouting, hey subclass, you want to be a real honest-to-goodness class? Then you have to write the code for this method. No excuses.
Okay, this little code snippet here shows you exactly how it works in practice. So you have an abstract class, A, and it's got this abstract callMe method. It's incomplete, right? It also has a regular method, callMe2, which is totally fine. Then along comes class B. B extends A, and because it wants to be a concrete, usable class, it provides the missing code for callMe. It's literally filling in the blank spot from the blueprint, completing the puzzle.
So let's just quickly break down why this is so cool. Class A is the blueprint, and it's not finished. It lays down a rule, the abstract void callMe method. It's a command. Then class B comes along and says, okay, I'll follow that rule, and it provides the actual code. This whole idea has a really cool name, subclasser responsibility. The parent sets the what needs to be done, and the child, the subclass, is responsible for the how it actually gets done. All right, you've got the main idea now, which is awesome. So let's do a quick run-through of the rules of the road. These are the must-knows, the do's and don'ts for working with abstract classes. Getting these right is key.
Okay, first up. Yes, an abstract class can have a constructor. Now that might sound weird, right? Because I just said you can't use new on it. But think about it. The subclasses still need to call super to initialize any shared fields that live in the parent. So it's for them. Next, and I'm going to say this again because it's that important, you can never, ever create an object of an abstract class directly. New abstract class? Nope, not going to happen. And finally, you can't make a constructor abstract. It just doesn't make any sense.
A few more quick rules. So, if a class extends an abstract class, it has a choice to make. Choice 1, it implements every single abstract method it inherited. Or, choice 2, it chickens out. It says, you know what? I can't implement everything, and it has to declare itself abstract as well, basically passing the responsibility down to its own children. Also, static methods can't be abstract. Why? Because static methods can't be overwritten, and the whole point of abstract is to force an override. And last one, a method can't be final and abstract at the same time. They're polar opposites. Final means never change me, and abstract means you must change me. Can't be both. Okay, now for the question that every single Java developer asks at some point. Abstract class versus interface. When do you use which one? They can feel kind of similar, but trust me, they are built to solve very different kinds of problems.
let's clear this up once and for all. Here's the simplest way to think about it. Use an abstract class when your classes have a shared identity, when they have an is-a relationship. A rectangle is a figure. A triangle is a figure. They are closely related, and you probably want to share some code or some fields between them. Now use an interface when you're defining a shared capability, a can-do relationship. You're describing something an object can do. A bird can fly. A plane can fly. A superhero can fly. See? They aren't related at all, but they all share the same capability. That's what an interface is for, a pure contract of behavior.
Okay, let's bring it all home. We're going to circle back to our original problem and put all these pieces together. You're about to see how this one little keyword, abstract, goes from being just another language feature to becoming one of your very first and most powerful tools for building really solid, flexible software.
And there you have it, the complete, elegant solution. Our figure class is now an abstract class, and its area method, it's now abstract too. That is our official contract. And look, rectangle and triangle both extend figure, and they each provide their own specific code for the area method. The whole design is now just clean. It makes sense, and it's totally safe.
So, what's really happening here that makes this so powerful? Well, the figure class now acts as our enforcer. It guarantees every shape will have an area method. And here's the coolest part. We can have a variable of type figure, but have it actually point to a rectangle object. Then when we call f.area, Java is smart. At the very moment the code runs, the JVM looks at the actual object sitting in memory and says, oh, that's a rectangle. I'll run the rectangle's version of area. This right here is called dynamic method dispatch, and it is an absolute game changer in object-oriented programming.
So when you start using tools like this, you're making a huge leap. You're not just banging out lines of code anymore. Nope, you're thinking bigger. You're thinking about relationships, about contracts, about who is responsible for what. You're designing a whole system. You are starting to think like an architect.
I want you to really let this idea sink in for a second. This quote just nails it. Abstract classes let you define the overall structure, the big picture. But then you get to delegate the nitty-gritty details to the ones who know best, the subclasses themselves. I mean, who knows how to calculate the area of a rectangle better than the rectangle class? It's a brilliant way to separate what needs to be done from how it gets done.
So here's what I want you to take away from all this. Abstract classes aren't just a language feature. They're a powerful tool for design. They let you enforce rules and build systems that are both strong and flexible. And I'll leave you with this question to chew on. In your own projects, what other kinds of contracts could you create? Where else could you define what needs to be done and then trust your subclasses to handle the how? It's a powerful way to think. Thanks for watching.